Hi, this is Charlie Berger, Senior Director of Product Management at Oracle Corporation for our machine learning, AI, and cognitive analytics technologies in the server technology, or in other words, database and data management uh, areas of Oracle. And perhaps like you, in 2002, I saw an amazing movie, Minority Report, with Tom Cruise. And it really made an impression on me, not for um, the science fiction nature of it, but for the more or less possibilities or the reality of it, how close we were to that in my impression, in my mind. As you can see, I work in machine learning, data mining, applied math area. Work with a lot of very smart people here at Oracle. We do amazing things. And when I got out of that movie, I thought, that's pretty possible. I don't see that as being so far-fetched. And so this presentation is really addressing that. And it's also inspired by a recent book that I've read called The Naked Future. I'll go into that just a little bit more. But those two, I guess, events really have had an impression on me. And the reason that it rings so true is Oracle's strategy, what Oracle's been doing. Because at Oracle, what we've had for a strategy is to move the algorithms, not the data. And when you do that, things like Minority Report, things like the type of new scenarios and possibilities that are written in this book, The Naked Future, what happens in a world that anticipates your every move, all of those things become so much more possible. So this presentation will go through that, but the main architectural change that Oracle has done that I think makes all this all the more possible is that we've moved the algorithm to the data. Unlike other traditional data analysis, statistical packages, machine learning, data mining solutions that require you to take extracts of the data from your data management platform, at Oracle, we've taken a different approach altogether. We've said data gets bigger and bigger and bigger each year, and data at some point becomes so large that it becomes almost immovable. And it makes no sense to move all the data to some other location to calculate a median, or to do a t-test, or to run a decision tree, or a logistic regression, or a neural network, or you name it, whatever. What makes much more sense is to bring the algorithms to the data, and that's what we've done, and that's what I'll discuss as we go through this. Here's our traditional safe harbor statement. And so I mentioned the book, The Naked Future, written by Patrick Tucker. It's a great book. I highly recommend it. And he starts out with many different scenarios that he talks about as the very, very near future. Not necessarily today, not tomorrow, but something that's imagined as being possible in the very near future. So I'll talk about that. I'll talk a little bit about the not so distant past. I'll talk about our capabilities. I'll talk about where this takes us, being able to actually do more of solutions. I'll tell you how to get started, and at the very end, I'll talk about our user community, the Analytics and Data Summit that's coming up. Actually, that's 2018. I'll have to correct that. March 2018. So imagine today, you're on your Droid, you're on your iPhone, and you wake up in the morning. I'm in the Boston area, and I get the local news, and I get some latest update about something that's going on in Boston. And I might get the local news, the local weather, might be my stated interest, my favorite sports teams, the Boston Celtics, the New England Patriots, the Red Sox, that kind of stuff. And I might get some national news updates, traditional stuff, right? Now, imagine a slightly revised future, something that we call the naked future. Now, tomorrow, let's say in the near future, I wake up and my Droid tells me, if I read the Droid, it says, when you meet your old girlfriend at the coffee shop this morning, act surprised to learn that she's getting married. Huh, that's interesting. So in the book, it goes on to say that this person goes and meets his old girlfriend at the coffee shop. And he says, oh, by the way, congratulations on getting married. And she sort of recoils and says, what do you mean I'm getting married? Who told you that? How did you know? He goes, scrambling. He says, well, I don't know. Maybe I heard it I think I saw it on your Facebook post. And she says, I didn't post anything to anybody anywhere. How did you know? How did you know? And it becomes, kind of confrontational in the book. And so if you look at the, very near future, the possibilities there, you can see how this could have easily happened. You're collecting a lot of different data from different locations, different places, and you have maybe this person, the girlfriend, changed her address recently. Maybe she's moved in with a boyfriend, or moved out of the house into an apartment, or who knows what. Maybe they've recently adopted a dog. Maybe they've had a lot of Facebook pictures of the two of them together. Maybe there's some tweets of I'm so in love, things like that, looking forward to spending our life together forever, things like that. And maybe there's an online ring purchase from Amazon or um, jewelry store, some sort of purchase of a large ring. All these things are quite possible. So uh, it is very real. So now taking that a little bit further, imagine I get I get called at school. I get a call at school, a notice on my droid. Charlie, please pick up your daughter before the 205 science class, where she would be sitting next to Joey, whose grandmother is elderly and is at risk. So, maybe the grandmother has some DNA that's been captured and stored in the medical records, and maybe there's a probability of her having some sort of problems or encounters with this disease, and it says that my child should not sit next to Joey because there's a certain percent chance that Joey would get it from my child. And all of this is sort of known because they know the location and status of the kids at school. They know the distance between the chairs through GPS, and everyone has a phone or a GPS. They know the relationships between individuals, either through Facebooks or later on LinkedIn, whatever the different sources are. They also know about genomics and exposure to the various different health risks that are available more and more and more these days with the various different sources of medical and healthcare data. So this is not that far fetched and far afield in my mind. So now I want to back up a little bit, back up perhaps quite a bit. But remember the plague? Remember the plague? It wasn't actually that long ago. But the Black Death, as it was called, was one of the most devastating pandemics in human history. It resulted in the deaths of 75 to 200 million people during quite a stretch there. So remember the plague? Well, um, I want to point out that predictive analytics are trying to do data analysis is not that new. And way back then, when they did the analysis over those years, over some long period of time, and kind of looking back, they found out that the bacterium was the Yersinia pestis bacterium, and that was brought in, most likely carried in by oriental rat fleas that were living on the black rats that were regular passengers on the various merchant ships that were traveling back and forth. And so, spreading throughout the Mediterranean and Europe, the Black Death is estimated to have actually killed 30 to 60% of Europe's total population. So, big phenomenon going on, right? You'd think a lot of people were analyzing this data and thinking about things and looking at correlations. Well, there were actually several outbreaks of the flu, of the Black Plague over this period of time. And this went on and on. And what happened was, at times, people got a little superstitious and they thought maybe this was related to the common house cat. There were superstitions. The population came to fear cats as consorts of Satan, and that the innocent cats were starting to be killed by the thousands because people thought, oh, it's the damn cat. Kill the cat, and we'll get rid of the plague, and my relative or my spouse or my loved one will revive and do better. It's all the cat's fault, right? So we all know that was a little bit crazy, but desperate times. So eventually, the cats get their revenge, of course. The fewer and fewer cats that were around, the rat populations increased unchecked. And so more and more rats, and the plague grew even more widespread. So it all sort of came back and circled back upon everybody. Fortunately, better senses came around, and the cats were allowed to live. The rats went away, and the plague eventually was kind of squashed out. But the cats kind of got their revenge back on mankind. But if you look at this today and you say, couldn't we have predicted this outcome today if we had data and machine learning algorithms? Could we not have figured out the correlations and the patterns of where all these diseases were coming from and going to, and what were the sources? And the answer is, I think, a very clear. Of course we could have. Of course we could have. This is pretty damn obvious when you look back at it now in modern times. But so now I want to fast forward to today. And today, if you look at the kind of things that we do when we try to transport our knowledge into a predictive model that we deploy somewhere, it's really not so dissimilar to this picture that I have from an old science fiction movie. It's really, a lot of trouble, a lot of effort that goes into taking a model that was built elsewhere, maybe in a traditional statistical or data mining package or a Python or what you name it, whatever kind of package. And I want to deploy that now into my OLTP or my operational or my enterprise system. It's a little bit like what you see in the picture. So again, back in the book, if we sort of fast forward a little bit and kind of take our
our time tunnel to the future and say, well, let's go into the future and let's imagine, how this might turn out in a not so distant future. So let's take a look here. Well, things are quite different. Now we have in the very near future, we have a big data interconnected world and lots of machine learning capabilities, and even on the verge of what some might call artificial intelligence. Although personally, I'm a little bit wary of that, having used to have worked at an artificial intelligence company back in the 80s and early 90s. Um, but regardless, you're getting more and more data, more and more machine learning. You can anticipate and predict things more than you ever could have in the past. And part of that is because of the extent digital exhaust that people leave as trails of data behind them. They leave their GPS coordinates wherever they move around with their phones or more in their cars or whatever they do. Tweets, the locations of those tweets for a certain percentage of people. They reveal where they're coming from. You have geotags, you have Facebook posts, you have pictures of this political candidate or that political candidate. You say, I like or I don't like. You have LinkedIn, you have RFID, you have medical records. There are huge, huge, huge sources of data. And even if you think all this data is protected, we've seen way too many hacks into systems where that data is tapped into, it's stolen, it's shared, it's bought, it's sold. There is a lot of data out there these days. And so there's a couple of quick comics that I kind of threw in here for a little bit of fun after that plague story. But the IRS says she'll be happy to hear that big data confirms that we can't wring another penny out of you. And that's probably a very real future, not so far future. Or this other one here that says big data and predictive analytics are coming after you. They predicted that you're the next one to perhaps die or something. So just a little bit of levity there after the plague. So there are a couple other things about big data and machine learning I just want to kind of bring up and put out there because I found these were sort of contextually relevant. There's a lot of discussion about big data analytics and there's a lot of urban myths. Now, both these stories are really true, but there's parts of the stories that were maybe a little bit overtold. And the one about Target is the most interesting one because I've heard this from people that, sort of firsthand knew the people that were in the room, people that knew claim they knew or met the father that was in the story. But so it's all a little bit murky. I've put the links into the bottom so you can go back and take a look at this. But the way the story is told, it's from Target and it's based on a new purchase of pregnancy-related items that Target sends a congratulations on your new baby promotions to the house. And the father receives this mail, opens it up, and it's all news to him. And he confronts the daughter and finds out that she is in fact pregnant. Unbeknownst to him, he contacts the store and says, "How did you possibly know?" And there were a lot of stuff about that. Now, this has gone from being a story that was told as you can imagine a scenario like this to they actually were targeting people who had purchased these kind of things, and they were saying, well, these kind of things could happen, but whether or not there was actually a daughter and actually a father was sometimes it's in dispute. And I've heard the story multiple ways, and I think probably partially due to legal exposures there. The other one, the beer and diaper story, is one of the very, very original ones that you've probably heard. Anybody here has probably heard of the beer and diaper story, and the way that it goes is that I guess it's the way it's told is that the wife, and I've heard it both ways, but the wife says, "Oh, honey, on your way home, can you pick up some diapers for the baby?" Actually, nappies. I think I've heard it's over in Europe sometimes, but it's either Walmart or Roscoe Drugs in the United States version of the story, and and the husband, when he would go in, he would say, "Oh, well, if I have to spend the weekend at home, can't go out because of the taking care of the baby, I might as well just watch the game and I'll get some beer." So they noticed this high correlation between the sale of diapers and beer. So this is where the story goes a little bit further afield. And so then they say, so therefore they put the beer and the diapers next to each other, almost as a product bundle. And then Walmart or Osco started to make lots more money from this market basket observation. And that last part of the story, I think, is where everyone agrees that it went a little bit further than the actual story. And if you read the links down at the bottom, you can follow up on that yourself. So where are we in this? If you remember the 2001 Dawn of Man scene, I think this is where we are. I think we're at the very, very beginning of what the possibilities are. And I'll go through a little bit more of a contextual backdrop to kind of make my point, and then I'll talk a little bit more about what Oracle has to offer in this space. But if you look at where this is, some big notable moments in time. If you look back now, I had fun doing this because there are so many of them, but some of these just kind of saw that, and I said, that did ring true, at least with me. So there was the old story of Garry Kasparov, the famous Russian chess champ who would play IBM Deep Blue. Kasparov did win the first match, so hooray for humans. But the second match, he lost in New York City in 1997. So 1997, it's a long time ago, losing to a computer. You've all seen Jeopardy and Watson. A lot of press has been made on this one, and that was sometimes they say, well, is that just trivial? It's just a search. It's not trivial. It is an amazing feat to have done that. Now they've had a lot more overhype in my mind on what they've done there, but it is quite impressive accomplishments. Here's one that's a little bit more of a personal one. The fellow there in the picture is Pablo Tamayo, a guy I've worked with for quite a number of years. He's now, used to be at the Broad Institute. He used to work with me at Thinking Machines. He's now at the University of California, San Diego Supercomputer Center, working on biogenomics and such. But in 1999, he wrote a seminal paper on the analysis of gene expression data, trying to separate out different types of leukemia using the genomics of the patients. And if you better knew which type of cancer you're dealing with, through looking at this, you could kind of predict what was going on, and you could then take that even further, which drugs might have the best thing to predict to have an outcome and control this. And at the time, it was pretty much breakthrough, and it's one of the very highly referenced papers in that field. Another one that's kind of related to this, my daughter actually has done a little bit of work with this, and that's how it was brought to my attention. But apparently, in the agricultural business these days, you can put these pedometers on the cows, and I'll say when Bessie becomes ready to have a baby, and she's becoming, I guess you'd say, more fertile, apparently they start having happy feet. They move their feet around quite a bit. And if you have a pedometer, a motion detector on the cow, you can pick this up, and then you kind of do the artificial insemination thing. And in fact, it's more scientific than that. If you know when, and you can have 1,000 cows, and you can cycle them all at the right times, you can also time with a great amount of accuracy whether or not it's going to be either in the purple a female offspring, or in the blue a male offspring. So you may or may not find this in your taste or not, but it's what people are doing, and it's using big data for better milk and agricultural production. Another one that's written in the big data book that's kind of interesting is this idea of this called BARTQL, movie script predictions. And basically, without going into the detail of it, you can read the links. He says that he can say whether or not there's a sword, or pirates, or a love interest, or a love interest who dies at the end of the story. And there's all these different, call it pieces of elements of the story that are themes, and we would call it text mining on steroids. But they can predict which movies, which scripts are likely to make the most amount of money. So they actually have the budget. Do you buy that movie? What's the probability of that movie going to market and being successful? And it's almost like picking wines early on in their life. Is that going to be a good wine or not? You do the same sort of investment in movies, and it's had very amazingly good results. And the authors can actually change the story. And in this case, it picks Ex Machina, which I watched. I thought it was a great movie, and most people would think maybe it wasn't. But if you look at their prediction, for at least a lot of us, we thought it was a pretty good movie. And here's one that just blew me away that was in the book, and it said they took a certain window of time, I think like something like 3 or 4 months of data on people with their tweets, and a lot of them were anonymous tweets, but some of those tweets were actually geotagged, and then your network and relationships and who you were tweeting to and from, they in the paper, they claim and produce evidence that they were able to predict with a great amount of certainty where you would be, I think within a city block or less, 1.5 years in advance. So it was just an amazing anticipation and prediction of what would be happening, simply based on random tweets in New York City. And that just, we've seen the movies, we've seen the different things, but that just sort of is pretty impressive. LinkedIn, not too many more of these. LinkedIn has now a new feature, a new capability that you can see the probability that you are a match for a position. So this is a little bit of text mining, a little bit of data, something that we were actually starting to work on here at Oracle with the Taleo guys. And LinkedIn, who specializes just in this area, already has something like that going on. So that struck me as, well, that's pretty interesting. That sort of validates what we were about doing. And then this is one that you're starting to see more and more. If you go to your gas pump, not only do you just see music and a commercial for, Eat at Sam's down the road or whatever, but now you're starting to get personalized gas pump advertising that says, oh, this is Charlie Berger's credit card, and Charlie Berger, is running low on milk. I should recommend milk, or whatever it is. They're going to give very personalized recommendations. So, and then the last one, I think, if you really want to get kind of freaked out, this is a great story from Newsweek that talked about Cambridge Analytica, that was became quite famous in the recent presidential election. They originally did all this work for Ted Cruz, and they go through this uplift modeling concept that says these are the people that with a little bit of boost, a little bit of poking them with a pointed idea, you could get them to go to the polls and vote. And so there's actually a YouTube presentation by the head of Cambridge Analytica there, who goes on, and if you watch the YouTube, it's fascinating because he says this is the kind of data we have. These are the profiles, those pie slices are different sentiments of different people with different topics and different issues and different styles of people. He goes into a great amount of detail. He says, imagine we could go all the way down to the 45,000 Republican caucus goers who needed a little bit of more persuasive message. They were very low in neuroticism, quite low in openness, and slightly conscientious, whatever that meant, but it was meant for him. And one of the issues that they found, one of the attributes that was a driving factor for them was gun rights. So you would have some sort of provocational message that would kind of get them going. And he says, let's say, imagine, let's pick a person. And he actually, in the presentation, drills down to a particular individual, and he shows that I've highlighted in red, but there was actually a guy in there, Jeffrey J. Roust, a male, and his GPS coordinates, where he is, and that's the guy they're going to go after. It became that precise. Now, they immediately deleted, references to this and sort of de-emphasized that, but it's very, very real, and this is what was among the various analytics that were used in the more recent presidential elections. Um, Images. Nowadays, you can do facial emotion detection. These are things that we're working on in the back, and I can't say anything about when and where or whatever, but nowadays you can take images, and based on the images, you can have probabilities of certain kind of outcomes or emotions. And you can use that. If I'm at my ATM machine and I'm looking like the upper right picture there, I'm very unhappy. Maybe they want to say, oh, you want to, we've given you a higher interest rate on your savings account or something. I don't know what you might do, but maybe then at the end I'd look like the picture at the bottom and be quite happy. But those are just additional data sources. I don't mean to imply that they're the only data source. They are additional data sources. And then I don't know how many of you go through 23andMe. I've done it. It's a great thing. My family's done it. And they take your saliva and they sort of get your genetics, and they can also predict your likelihood to have certain diseases based on that. So it's something that I think is becoming very, very real, very important to add to your medical file going forward, as we go into this near future. So where is all this going now? Well, actually, there's a couple more here. There's even an app that's mentioned in the book. I downloaded it, I tried it out, and you say, well, what's your environmental profile? How green are you? If I use reusable shopping bags versus plastic bags, if I get a hybrid car, you can actually predict your impact on the planet, and that's quite an interesting application. And here's one that was mentioned in the book. There is an 80% probability that you will regret this purchase. And that's kind of interesting because, most of the time they say, you need to buy this, you need to buy this. But I think if we go towards the future, who knows? There will maybe be even things that say, don't buy this. It's a bad idea, Charlie. Don't go there. So let's see, where is all this going as we travel through space and time, and we've seen all these different things come and go. What's the very near future? And I didn't even bring up Alexa. Don't get me going on Alexa, but I do predict that in the very near future, Alexa, listening to all the comments and conversations and opinions that people have, will probably be the best predictor of who's going to win the next election, the better predictor than anything else. So where is this going today? Well, it's still the basics, right? And in the basics, you have to have good data, right? You have to have a place to store your data. This is where I think Oracle can play a role here. But it's not just the data, it's the data and the domain knowledge. And that's the most important thing. You need to know the data. You need to know it's not just your bonus amount this year, it's your bonus amount this year versus last year compared to your peers. It's the rate of change of the amount of opioids that you're taking compared to what you used to be doing. It's all these temporal kind of data and comparative and derived variables that are very specific. Has nothing to do with the machine learning algorithms. They're the most important thing to get you started. So there are, of course, machine learning algorithms. And Oracle has, fortunately, great libraries of all of these. We have about 30 machine learning algorithms that run in the database. We have a similar about 30 machine learning algorithms that run in Spark and Hadoop. So you got to have the data, you got to have the domain knowledge with the data. Those kind of go together in my mind, the algorithms. And then what does that generate? That generates models, predictions, and insights. And it makes you feel like that. Although that's it's a little bit science fiction-y, but we're really from a more practical point of view. It gives you the ability to hit your customer with the right product, the right time, anticipate things, know what's fraud, knows what's a healthy outcome, and really have much greater insight into the I guess future of your customers. And so that's all important, but the most important thing is to operationalize this, because if you don't deploy and operationalize your analytical methodology, you just have a list of customers on a piece of paper. You have an interesting report. You have an interesting pie chart, but you need to deploy that. You need to operationalize that. And if you remember what I said in the beginning about how Oracle brings the algorithms to the data, that changes everything. So now I'm going to talk a little bit more about what we have for product offering. But before I do, I took this picture of this presentation, and I just want to take a quick picture because thank you for being here. It's a great audience, and I want to tweet that off. Had a great talk at Oracle Open World. Thank you. Press send, tweet. So people do that all the time, right? So now I'm going to talk a little bit more about the features and functions that we have. And first, I always like to show this Dilbert comic because it still makes me laugh. And Dilbert says, I am working on a framework to allow construction of large-scale analytical queries on unstructured data. And she says, ooh, I'm a little turned on by that. And he says, settle down, it's just a framework. And that's my point. It is just a framework. I don't have solutions for, you've seen some of the other things about focused applications for adaptive intelligence or chatbots or anti-money laundering systems. I don't have any of that. You can certainly build those kind of things. What I have is a framework or a platform where we've extended Oracle's data management platforms, the database and the big data Hadoop Spark environments, and pushed machine learning into those and embedded machine learning capabilities into them. And when you do that, it changes everything. So here's what we have today. We have a lot of platform sprawl. We have one system for data management, another system for data management, maybe several systems for data management, and then multiple systems for doing the analysis, whether that's open source R, Python, Spark, SAS, SPSS, you name it. This has many inherent problems. It has complexity, it has data movement, duplicated data, security exposures. You have one system where you're storing the data. You have a duplicate system where you copy the data over and analyze it over there, and then God forbid you have a good model that you've developed. How do you operationalize it? Well, the answer is it's a mess. So we say, stop the madness. Don't do that. It just doesn't make any sense. And so if you look at what people generally do today, they take the data, they take an extract of the data, and they use their favorite tool. We say, stop, don't move the data, leave it right where it is. Furthermore, if you go back to the left-hand side, you say that it's actually quite complicated, right? Because you have all these derived variables, you have assembling of the data wrangling, dealing with, I don't know, missing values is the one that's always mentioned, although that's not that critical. We automatically handle that for you in part of our system. But a lot of it, I think, is the derived variables, like the change in your blood pressure over time, or the amount of checks that you're written, or the bonus amount this year versus last year, or do your comments or your tweets ever include the word frustrated or angry? These are all pieces of data that need to be extracted, pulled together. And what we do at Oracle is we move all of this all these analytical capabilities, and we embed them as native capabilities inside of our data management platforms. At the core in the database, they're SQL functions, and at the core in Hadoop and Spark, they are implemented in Spark oftentimes. This is why is this relevant? It's relevant because if you look at a study done by the Data Warehousing Institute, this is done by Fern Halper, with whom I spoke not that long ago, and she was telling me that the industry average was actually 9 months. Now, on our graph, it looks like more like it's 3 to 5 months, but she said it was 9 months. And I don't know that it's quite that long. I always thought it was more like 3, 4, 5, 6 months maybe, but it's a long time is the point. And this is because probably the traditional tools you're using are those. Now, some other ones are doing days and weeks. My customer references, if you see various different customer references that we have these days, they're all much more in the top category. They're using days and weeks amount of time to deploy their models. So that's the advantage you get from building the models in the same place where you store the data. So how do we do that? We the data remains in the database and in the Hadoop Spark environment. The model building and the model scoring occur inside the database. You can use R packages with data parallel invocation. So if you want to do something custom, you can do the data preparation inside the database, which is like data aggregations for sales data or so. And if you want to use some special R package, you can do most of the work in the database and then do a call out. But we do have 30 algorithms that are high performance algorithms that you can use GUI, R, or the native SQL to drive those algorithms. So you're leveraging your investment in IT, and depending on the user, you can use a drag and drop GUI or whatever. But the main point is that you do not have to do all this data import, data export. You're leveraging the parallelism and scalability, security, your everything that you like about the database's ability to use the optimizer and all that to just screen through data and give better, faster reports and support OLTP environments. Well, you can now do the same thing by just switching on those features, those capabilities inside those data management platforms. And as I said before, versus weeks, or I guess I'm hearing months, versus for us, it's minutes or hours to deploy a model. So what is it that we have? We have a machine learning platform with parallel scalable machine learning algorithms and very important integration with R, where we both push down the R language into equivalent matching SQL functions, say for a decision tree, for a clustered algorithm, or an aggregation, or computed variable. We push down dplyr, things like that. And then if you want to do something else beyond that, you can go do a call out to open source R. But you can use the drag and drop GUI for citizen data scientists. You can use open source R Studio for the R enthusiast. And the user interface is all the above. Citizen data scientists, R users, developers who want to use SQL and PL SQL to deploy some sort of application. It's a very sort of robust, complete environment. And the algorithms run, as I said, both in the database, on the cloud, in the big data appliance, and in the big data appliance cloud that, of course, is using Spark and Hadoop there. In terms of the algorithms that we do support, it's quite a range of algorithms. In classification, we have, about 10 or more algorithms for classification, naive Bayes, logistic regression, decision trees, random forest, support vector machines, and so on. Same thing for clustering, regression, and so on. Now, what's different and unique about these things is they are just natively part of the data management platform. So if you want to use, let's say the database is partitioned by, and I want to build a model of who's going to likely vote for this political candidate or that political candidate, partitioned by state, it's going to launch 50 different models just using the partitioned by capabilities of the database. If I want to do partitioned by state and gender, it's going to now launch 100 different models. And so all of the capabilities of the database are in play because I'm essentially just letting the data scientist and the citizen data scientist, under controlled supervision from the DBA, inside the data management platform and do their analysis there. I can do call outs to any arbitrary R package, although I do pay a price when I do that for sending the data out there. But a lot of the data, the real advantage is being able to push down to the equivalent SQL functions and using these algorithms, but from an R API, an R language API. And one of the new things we've just added is a couple of things that we've added. Time series over on the far left. Well, you can talk to me offline on that. We've always had the anomaly detection for a while. We can also do text mining support. So if some of your data is unstructured data, we use Oracle text under the hood to do that, to tokenize that data and bring in a vector of words. And then down on the lower right, one of the newer features is the ability to export a model. Because you may want to build the model in the data in Spark and Hadoop, or build the model in the database, but then you want to deploy that model out into a streaming situation. Or I always joke, if my toaster could run Java or C code or Scala, I could predict if the toast is burning by a deployable model that I published and embedded into the logic of that appliance. So sort of in total, what we have then is the database. And today at Oracle, everything's drawn as sort of the cloud. You have the database with embedded data mining, machine learning capabilities and statistical functions, integration with R. You also have the big data appliance on the left, either in the cloud with Spark and R implementations of other similar but parallel types of algorithms. You have big data SQL that unionizes or joins these two things together. I do think there's the opportunity to boil the data lake on the left and integrate that data to the data on the right. And then you have the data scientists, the R users, the data science, citizen data scientists that use the various integrated development environments on the left to build the analytical models. And on the right, you have the people that consume those analytics, the business managers, the functional users, some person that has it pop up in a window as a result somehow. So with Oracle, what we're trying to do is manage and now analyze all your data. So manage and analyze all your data If you have data over here in Spark and Hadoop and NoSQL, I contend that you can build your models over here using the models that are there, and that's what many people do. I think you also have a very logical situation where you boil down that data into what are engineered features like counts or totals or changes over time, or how many events did you have where the refrigeration truck temperature gauges went above 40 degrees for more than a half an hour. Well, that's an event. If I'm trying to worry about my ice cream sandwiches on my way to Boston, should I put $5 into the vending machine to get that ice cream sandwich if I know from big data that maybe it got warm on the truck 5 different times? So I can do that on premise and in the cloud. So why Oracle? Well, this is what Larry Ellison last year at Oracle World, he said, because that's where the data is. If you're going to analyze the data, you don't want to bring it somewhere else. Oracle has the data. Why would Oracle succeed? Because that's where the data is. Why do they rob banks? Because that's where the money is. And this is the same kind of logic here. So here's a situation I want you to kind of ponder for a minute. Look at how easy this is. If I have a bunch of data and I want to use a machine learning model and build some sort of functional model, some sort of using a neural network or decision tree or clustering algorithm to build a particular model, I can make a prediction. What's the value? I can say it's very high or medium. I can give a probability of it being very high or medium. Not so hard, right? But if I can do that, and I can do that in 1, 2, or 3 or 4 minutes using the parallel scalable algorithms that we have built into our data management platforms, and that's what we do. I mean, less than 5 minutes to build these models. Then I might as well, if I'm done with this by lunchtime, I might as well think about, well, there's another thing. There's bank funds. Why don't I do a predictive model for bank funds? And you notice here, this person here has 0, but I predict they should have $4.5 million. Here's somebody with $6 million. I predict they should have $35 million. So this is interesting. If I now have done this and I have this actual versus predicted, it's kind of interesting to highlight the ones that are both opportunities to have a conversation with the customer about, hey, I know you only have $6 million. I know you have $6 million, which is a lot, but I think you got even more that you want to put more money in our bank or our system. So there's a lot of opportunities to do sort of comparative things of actual versus predictions. If you take this further, you can imagine even more things. There's checking amount. I might want to do a prediction on checking amount and do the same sort of comparative thing there. And so you can kind of see where I'm going. Every variable that's in the data management platform that you're bothering to store, you could, in the naked future, have a predicted variable for each one, a predicted value for each of these things. And the actual versus predicted difference becomes interesting. So with Oracle, how do you do this? Fortunately, there are many other different products and complementary things that you'll see. And the Oracle Analytics Cloud offers data access, data wrangling, data visualization, great tools for kind of getting your hands on the data, figuring out what's going on. With Oracle Advanced Analytics, we have the drag and drop Oracle Data Miner graphical user interface. The models themselves, when we build them, are just a prediction probability function. So I can do that in real time. If I change these values, I'll see 83% probability that something's going to happen. If I change that, I'll get a whole different on the fly. So I can deploy these models in OLTP situations. I can deploy them on my Droid use cases as I described before. If I have R, I can use R, and notice I'm logging in, I'm entering these little packages. What do the packages do? They do the handshake between open source R and the database, and they make the push down. So when I type in something like summarize, I'm going to get, or here in this case, aggregate, it's going to do the mapping transparently. It's going to map it to the equivalent SQL. And so there's an equivalent SQL that's going to scream through the database and wildly parallelized implementations of that, bring the results back, and the R user thinks they're using R, but actually they're harnessing the whole 512 degrees of parallelism of the database, and the data never left the database to do this. We're announcing something new this year at Oracle. It's called Oracle Machine Learning. It is a Zeppelin notebook. So it's an addition. It's our expansion further, where we are adding beyond RStudio and the Oracle Data Miner GUI on the cloud. Notebooks are emerging as a pretty popular paradigm for people to work with things. What are notebooks? Notebooks are just systems that are, a modern notebook is a web-based, accessible by browser user interface for a data analyst to access, view, graph, and analyze data. They can interactively work with the data. They can collaborate. If I work on it and someone else works on it, we can interactively go back and forth, write our little notes. We can even use different languages. I can use SQL, R in notebooks. Each little paragraph becomes a different language opportunity, so I can collaborate and speak in multiple languages. So we're adding that as another notebook instance. in addition to everything else that we offer. And the very first instance, the very first release of this is coming out with a newly announced Data Warehouse Cloud Service. The Data Warehouse Cloud Service is, as you've seen Larry say, the autonomous database. You just kind of turn it on and it works. And now with that comes the Oracle Machine Learning Zeppelin Notebook, which is a collaborative user interface for data scientists. Now in release 1 on the Data Warehouse Cloud Service, for various reasons of it's using the PDBs underneath, and they've stripped away Oracle text, they've stripped away Oracle XML, DB, those kind of things, what we would store the workflows. This is a pure SQL API to access the data mining machine learning functions. Roadmap will, of course, add other languages like R, Python will have different backends for like the Hadoop and Spark BDA servers. That's the whole opportunity of these notebooks. And we'll have something more like an Oracle Machine Learning Studio type of thing that talks to many different platforms. So that's we'll also add images. There's a lot coming. But what's being announced today and what's available to people now, the beta program, sign up with the beta guys to do that. This is as of October 1, is Oracle Machine Learning Zeppelin Notebook as part of the Oracle Data Warehouse Cloud Service. And there's just another visualization. So very interactive graphics, very easy to use. You are typing code. And then over time, each of these paragraphs will become more as a visual pipeline. So that's, of course, where we'll go with the Oracle Data Miner workflows will be imported into the Oracle Machine Learning notebooks if that's the way you want to go. And you all now can work on the cloud. So you'll still have, of course, SQL Developer for forever, right? It's so popular. That's 1 or 2 million downloads a year or more. So you always can use that. You can use RStudio, similarly very, very popular. But this is yet another kind of a collaborative approach for data scientists on the cloud. Try it. I think you'll like it. And here's just a few quick screenshots of it. I have my notebooks. I go in to click on a notebook. I see the different notebooks that I have here. I may have a recent project. I might start a new project. Here's one where I'm predicting insurance buyers. I do select %SQL, select all the data from this data set. There's the data. I get to see it. I can insert images in here. I can do lift charts and show the lift charts. So up above, I've done some analysis. And I can have like interactive drop-down menus. So I can say predictions is for yes, predictions for no, and I can kind of filter things. Maybe have pie charts and other kind of mechanisms for doing that. So it's a very nice sort of emerging new paradigm for doing this. So remember the naked future. Remember where all this stuff is going to. So let's kind of wrap it up with a little bit of where this is all going to. So now, let's say it's the very near future. And I have, on my Droid, I have this new app I've downloaded. It's called the Best Next Activity. And I think I should go off and enjoy a nice dinner somewhere tonight. But I have a lot of nagging things at home I have to do. I have to fix the faucets. I have to do the yard work out in the back. I have to do some fixing some fences, some different things that I don't really know how to do some of these things. So maybe I should watch some YouTube videos. So in fact, what it's recommending for me right now is that I should probably just go back to the hotel room and order a take-in mac and cheese in a microwave and watch some home how to home repair YouTube videos. So when I go home, I can go back and do a lot of productive kind of chores, you know, my to-do list around the house. But it's the near future, right? And I want to assemble a lot of different data and make the best decision, because I don't want to just make the wrong decision. I want to have the best decision. So I have all my recent purchases. I have all my networks. It knows I'm out here in San Francisco giving this presentation. I have my whole sort of 360-degree view. I have my image analysis that knows if I'm happy, sad, where I am, what I'm doing. It's even got predictions on the fly, and I pull all these different things together, and I can make a very a better and better prediction as I go forward. So all of this comes together in the very near future, and I start seeing what I'm going to do next. So here, let's start predicting what to do next. Remember, this is the very near future, so a little bit of this is you know, kind of click our heels here. But we have a bunch of data, and somewhere in here is me, and there's the information about me. But now I need to join in here my Evernote notes of all my things to do, and I have to catch up on my emails, get some dinner, read how to repair books, do something fun while at Oracle World, deliver a great presentation. All these things are in my data digital exhaust stream. Also in there, I need to read all my latest tweets. So there's a bunch of different tweets going on about different things going on in artificial intelligence and different comments and stories. There's a whole stream, a digital exhaust of new data there I can consume. there's the weather. So let's join in the weather. I know that's going to be very sunny and nice this weekend. So now I'm going to join more weather data, select star from the weather forecast, join that into there as well. I was going to take an Uber car, but now I get this new piece of information from the roadside cameras, Department of Motor Vehicle Records, and this person's latest tweets. I found that the Uber driver that's on his way to pick me up to take me out back to my hotel just had a flat tire earlier. He's had a terrible driving record from the Department of Motor Vehicles, and he just broke up with his girlfriend. So all this is now out there in the very near future, and it kind of indicates maybe not the best thing for me to take this driver. So let's keep looking. Let's see if there isn't somewhere else to get there. So now here's another driver. It's the near future, and Lucy, an autonomous Uber car that I'm most likely to have now show up first. Well, Lucy, the robot, just posted an angry Facebook, a lot of angry Facebook flames about her recent breakup with Gianni, the robotic lawnmower. So maybe she's not the best person to be driving with either. So maybe I should walk to wherever I'm going to go to. And let's say I'm going to go out to eat somewhere. I'm going to go to the Oyster House, was where one of the options. I was going to have a nice meal. Well, we just found out that Johnny Five, the food robot prep, he was recently observed in the North Beach area, where they have recently received a shipment of tainted silicone spray lubricant. So maybe I should not eat at the Oyster House because of Johnny Five having some tainted silicone spray lubricant there in his system. So let's go back to my tweet. And actually, it's the near future. We've done a little bit of analysis here. And through facial recognition, we've said, hey, that's Brendan Tierney. He's an Oracle ace. He's an author. He's an expert. He's a great guy. He's sitting right there in the audience. He's geotagged as in San Francisco. Hey, I'm in San Francisco. Through LinkedIn, the system knows that he's tagged in my network. We both know each other. We're actually good friends and all. We know each other, and he's in the same place as me. In fact, he's sitting right there. I didn't even notice him. And in fact, he's a single malt whiskey fan. He loves single malt whiskeys, as do I have to confess. So this is kind of interesting. So what happens in the future? Well, now my droid is updated, and now it says, you know what? To optimize tonight, my next activity should actually be to enjoy a single malt whiskey with friends, catch up on my work emails, sure, and go see some other great Oracle open world talks on machine learning. But go off at single malt whiskey with Brendan. And in fact, it's the naked future. It's the very near future. It goes even further. It even suggests where we should go, and it makes a reservation for us. So this is not so fanciful. This is stuff that is coming. I think it's very possibly done using the Oracle technologies for all the reasons I explained. And so it's a little bit like Minority Report, where the precogs were replaced by machine learning. But the precogs today would be hopefully replaced by Oracle's machine learning and AI. And hopefully this happens a lot sooner than 2054. You can either think this is good or bad, but I think it's definitely coming, and I'm sort of a believer that the technologies are always good. So if you want to get into this whole naked future, if you want to go down this path, how do you get there? Well, there's a number of different links I always provide. They're in the handouts, they're in the presentation. You're welcome to go use these. There's even getting started. There's tutorials. There's a lot of different things here. So you can click on this or send me an email at charlie.berger@oracle.com. And we have our BWest Summit event. That's actually, we changed the name of that to Oracle Analytics and Data Summit. Actually, I'll have to correct that in the near future. And here it is right here, the Analytics and Data Summit in March 20 to 22, 2018. Please join us. Call for speakers is open right now. We're pre-selecting presentations and speakers, so if you submit early, we'll take the best. We'll skim those off the top and accept them as speakers. So please think about submitting things. It's meant to be a user group of everyone sharing their novel and interesting best use cases. And with that, thank you very much. Not much opportunity for questions in this format, but thank you very much for your time. Thank you.